This video is about how to charge a found lithium cell properly, and more importantly, how not to charge a found lithium cell. In a recent video, I featured vapour devices that can be found lying in the gutter on the street that actually contain a rechargeable cell of decent capacity. I've tested one of these cells. It was spectacularly good performance. And after I published that video, people said, oh yeah, I charged that myself by getting a USB lead, stripping the ends and putting it straight across the lithium cell and plug it into a USB charger. Do not do this. There are so many reasons not to do this, and I'm going to demonstrate them right now by showing you what happens and what could potentially happen if you do that. So here is a fairly beefy lithium, USB charger, and I'm going to plug a analyzer into this. This is a little Ruodeng analyzer. And keep in mind, you only really want to charge these cells at about 500 milliamps to 1 amp. If you plug it into a USB power supply straight as it is, two things will happen. It's gone to over 3 amps immediately, which is way too much current for that cell. And more importantly, the USB charger is going to try and charge this cell up to 5 volts, and you must not do that. It will not only potentially damage the cell and reduce the number of charge cycles you get out of it dramatically, but if you overcharge these cells above about 4.2 volts, which is their normal safe charging level, it can cause chemistry problems inside, not just depleting the lifespan of the cell, but it can actually make them fail. And when they fail, they can sometimes go short circuit inside. You'll get a jet of vapor coming out the end. If that vapor, which is combustible, lights, you'll end up with a little flamethrower. And if you've got this charger in your house and you forget about it, you might come back to a house fire. Just thought I'd mention that. Now, I don't want to be alarmist here. I don't want to make it out that lithium cells are a terrible thing. They're a great thing. They're one of the best battery technologies. But you have to treat them with respect. You have to make sure you don't physically damage them, and you have to make sure you don't damage the chemistry inside by overcharging them. So I'm going to show you some ways to charge these, and they will be based on these little modules you can buy from eBay. They're very cheap. You don't just buy one of them, buy a strip of them, because it's actually cheaper to buy them in bulk. If you go on eBay and search for TP4056 module, I'll provide a link down below to a search for that, then you will find sets of these available for sale. There are simple ones and there are complex ones. Now, there is another scenario with this. Some batteries that you might find that are salvaged from equipment do actually have a protection circuit built in. In that case, if you were to just slam current into these with a USB lead, it will still overcharge it current-wise, but it should actually cut off at the 4.2 volts, but it's not an ideal thing to do. The only thing that is limiting the current is usually the cable itself, and it's not an ideal situation. It's very unpredictable. Let me show you the circuit board that's in the end of this cell. It uses 2 chips. It's got the DW01, which is a special chip dedicated to protecting lithium cells, and it uses a little double MOSFET. The reason for the double MOSFET is so it can actually stop that charging when it reaches the upper level, and also if you over discharge it, it'll also cut it off to stop the battery being just run right into the ground. There are very few support components needed with these. I'm going to cover these because the same components are actually on one of these circuit boards. So let's take a look at that chip in the first place. The DW01A. This little chip has the MOSFETs, and if you connect the cell across it, it monitors the voltage across the cell with a 100 ohm resistor and a 100 nanofarad capacitor. This just provides basically a bit of decoupling for any sort of noise from the load that's connected, and it means that it can actually accurately monitor the voltage across that cell. It also does one other thing. It has a 1K resistor here, and it measures the voltage across these MOSFETs, and if it exceeds 0.15 volts, it will actually turn the MOSFETs off to protect itself. So that's the short circuit protection. That does not work when you're charging it, as far as I know, only when you're discharging it. But this thing is a sort of, it's useful. It will actually cut off at 4.3 volts, which is above the normal 4.2 volts, and it will cut off at 2.5 volts when you're discharging it. It's basically purely to prevent extremes from going too far. So let's take a look at the first of these modules you can buy off eBay. Then I'll show you how to hook some leads up to them so you can reuse your cells lots of times. I've got a little one here, a little module that I've doctored up that I've been testing. This is out one of these type of device. And this cell is rated about 500 milliamp hour, this particular one. I've ran several full charge and discharge cycles at sensible currents, 500 milliamps. And the first one, well, I missed the first few cycles because it's only after I'd done it a few times I thought I should be documenting this. And consistently it's gone, after the first few cycles, it went up to about 481 milliamp hour. And over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, plus all the previous ones, so let's say 25, it's at 485 milliamp hour, which is very respectable for a 500 milliamp hour cell. That is well within the tolerance, and it shows that, you know, these salvage cells have a lot of uses. So here's the first of these little modules you can buy off eBay. It's a fine module. It doesn't have that extra layer of protection. I prefer the other module that has it, but let's take a look at it. So we have the classic chip. This is a charge control chip, and it has a resistor here that sets the current. Most of these come set for the maximum current, which is 1 amp. And while that's not ideal for these, if you're not really comfortable with changing this resistor, this tiny little surface mount resistor, which you can also just replace it just by soldering onto adjacent pads that are bigger, you can just replace it with a 1/4 watt resistor if you want. But ideally for compactness, you'd replace it with another surface mount resistor. At the moment it's 1.2 thousand ohms, but if you change that to a 2.2 thousand ohms, it suits these batteries better, these little lithium cells, because it will charge them at 500 milliamps, and you can customize that. It means it'll take longer to charge than just the bare unit as received from eBay, but it will just treat the cells a little bit better and they'll last a bit longer. I shall put this device down. I'm not going to puff that. But this chip has other tricks. It shows you when it's charging, it shows you when it's completed charging, and it has various things that if the cell voltage is too low, it will start trickle charging it at 1/10 of the programmed current just to get it started gently. It also has thermal regulation. If it gets too hot, it will actually cut back the current itself. So the circuitry on this particular unit looks like this. The USB supply comes in and it goes to the chip via a 0.4 ohm resistor, which is it's shown in the data sheet, but many don't use it. I think they're relying on the resistance of the USB leads. But there's a 0.4 ohm resistor and a little local decoupling capacitor to provide stability for the chip. The current is programmed with this resistor here, and if you look at the data sheet for the chip, let me just grab the data sheet for the chip, because it's got a set of resistance values here. So it goes from the default value that supplied these modules, 1.2 thousand ohms, will give 1000 milliamps or 1 amp output. I experimented, I found 2.2 thousand ohms gave round about the 500 milliamps, which is just in between the 4 and 580 here. But if you've got really small cells, you can put in up to 10k as a resistor. You can actually go much higher than that, but they don't really document it. But that will charge at a very low 130 milliamps, which is ideal for really tiny cells. It's a very versatile chip. It's super useful. Things worthy of note. The chip terminates charge at the end when it detects that the current you've programmed, say for instance this is the as supplied from eBay, it's set for the 1 amp because it's got a 1.2 thousand ohm resistor. It's only when the current tails off to 100 milliamps that the fully charged indicator will light. It's worth mentioning that if you have a 500 milliamp hour cell and you're charging at 500 milliamps, then after an hour, even though it takes a while for it to do the final top off, after an hour it's got most of its charge. You could use it at that point without waiting for it to finish charging. The next charger from eBay is my favorite type. It adds an extra layer. Let's get this one out of the way so it's not got a little obstruction in the back. It has 2 modules. It has the classic TP4056. This one doesn't have that series resistor. It's got the same 1.2K, 122, 12 and 2 zeros. So it's got the same 1 amp resistor that you can change, but this has the extra advantage of having the DW01A and this MOSFET. Now it's worth mentioning that if you look at the tiny MOSFET package on this one, because the circuitry measures the voltage in the event of overload or short circuit, because a smaller MOSFET will have a slightly higher resistance, it means that it's capable of supplying less current before that overcurrent trips. This one uses a bigger one. I don't know what its current rating is, but generally speaking, the bigger MOSFET packages have a lower resistance, so they'll actually be able to put out a lot more current before it actually trips the overcurrent or the short circuit protection. I shall show you the schematic for this one. And then I shall show you how to make your little charge adapter. So in the case of this one, it starts off exactly the same as the other without that resistor though, that 0.4 ohm resistor. It's got the same 2 LEDs with 1K resistors. It's got the same programming resistor by default, the 1 amp programming. But the difference is that this one then has the protection chip as well. And that drives the MOSFETs, and it just provides that extra, it provides double overcharge protection. But more importantly in this case for my applications, I run strings of LEDs and stuff off them, and it stops it from over discharging. It cuts it off at 2.5 volts instead of just letting the cell go all the way down to the bottom. Because if you operate the lithium cells within their voltage range of about 4.2 volts down to about 3 volts or so, it just prolongs their life greatly. And look at that one that I've been testing. It's been getting great cycles. Okay, now to get on to making your little adapter for this. You can do 2 things here. If you're just wanting to jump onto lithium cells, you could put a couple of crocodile clips leads onto one of these modules on the battery output connection. But my preference is this little arrangement here where you can put a connector in the battery and you can then use it for powering other things via this other connector with all that extra protection. The advantage of this one, I have used it to top up cells in devices like this when refilling them with liquids and topping the cell up. It's very important that when you do that, make sure you don't short anything out and get the polarity correct. Double check the polarity. If you put this the wrong way around, it may actually blow up these modules. They might not be too happy about it. So to make up your adapter, use your favorite connector. Everybody has a favorite connector. These are mine. They're sort of little Molexy type connectors. There is a name for them. Can't really remember. Is it XH25? I don't think it is. Not sure, but there is a name for these connectors. I kind of like them, and make up 2 female connectors and 1 male connector. The male connector is to plug into the battery, because by making it up with connectors, it means that you can basically use it with multiple batteries. In the case of this one, I'd just not have a USB lead connected. I would just put one of these little connectors on. So I'm going to get the soldering iron on, and I'm going to bring the bits in and I'm going to show you how to solder this up. So one moment, please. The soldering iron is up to temperature. I've brought this up closer so we can see it better. So there are 4 connections on the output of this. B plus and B minus are the battery connections, and out plus and out minus are the load connections. So the first thing I'm going to do is I'm going to get some juicy lead-based solder. It's my preferred solder. And I'm going to put a little solder onto each of these pads. Now you could put the wires through the circuit boards. I find it easier just to actually solder them directly onto the pads. So let's get some solder onto these. Let's do this properly. The solder is actually going through because those are fairly plated through hole pads. Now the first connection I'm going to put on is the one that's going to the battery. So following the polarity here, just place your pre-terminated stripped and tinned connector onto their wire, onto here, and just flow it. Then get the positive and flow it on, being careful not to bridge to anything in the vicinity. Allow to cool. Then this is my output connector that I'm going to be using for loads. So we want to put the negative onto the out negative. Oop, get the solder iron in here. And the out positive onto the positive connection. And that is it. But for one small thing, I recommend putting a bit of heat shrink sleeving over this or wrapping it in tape, because if you have this floating about on your bench, there is a risk that things are going to get short-circuited. Okay, I'm just going to get this stuff out the way. I'll show you putting the heat shrink sleeving on, and then we can test this. We'll actually connect the battery. I'll tell you what, before I do that, here is the battery. Let's get the other connector that I have handy here, which is my little flying socket. And I shall just, sorry about the swamped out fingers, the lighting is really just focused onto a small area here. So when you're soldering onto these batteries, a couple of things to note. Don't linger too long. They do have decent tabs coming off. If the tabs, which are very fragile, snap, don't try soldering onto what's left of them, because it can cause problems. One of the tabs may be copper and one may be aluminium. Sometimes if you remove the bit that takes the solder as out the factory, you can't actually solder onto that bit. Just be careful. Also make sure that nothing can bridge onto the little pinched seal on these, because they've got a conductive sort of metal layer of foil inside. So after double checking polarity, take your positive connection. Hopefully this will be in focus. I think it's in focus. And reflow that onto there. Then get your negative connection. And reflow onto the tin pad. Now, it's important to note that these connections are not really load bearing, so I would recommend wrapping a bit of Captain tape or other tape over these just to actually reinforce them, to give them extra strength. It will just make it last much longer. Right, tell you what, I'm going to clear this stuff out the way and then we can test this. First of all, let's get the heat shrink on. Now, the heat shrink size I use is 12.7 millimeters. I think that's the sort of shrunk size once it's been shrunk down. It just seems a good choice. If in doubt, do what I do. Was this a good idea? Is this actually going to go through here? Yeah, it's going to go through there. And just buy a few different sizes. It's safer in the long run. Squish it over the module and over the actual little USB connector. That might be the hardest bit to get over. Okay. Now, use whatever you normally do to heat shrink. I use a little hot air pen. It's just as part of my soldering station. It's quiet, it's convenient, it's probably what I use it more for than anything else. I do use it for actually soldering and desoldering components and reflowing surface mount components, but it's very handy for doing heat shrink. I recommend the clear heat shrink simply because there are LEDs in this and it means you can actually see the LEDs. It actually helps spread the light around as well, so you can actually see even from the edge when the LEDs are lit. Right, technically speaking, I should be able to get a USB lead now. Oh, here is a USB lead. Actually, no, let's use this. Let's do the test properly. I'm going to have to find a USB lead now. One moment, please. I have the lead. I have also got a string of lights to demonstrate that this can be used to power strings of lights if you so desire. So let's plug this into here. This is one of these generic leads you get with random products from China. Hopefully it's the right polarity. Let's plug the Ruiding in and we'll see what current it charges at. So I'm plugging this in here. The little red LED has lit and the battery that I was previously hammering over 3 amps into is now getting 914 milliamps, which is a lot better. It's still not ideal. Ideally, you would change the resistor in this to 2.2K to actually adjust it to the 500 milliamps for the cell. But you know what? It's maybe worth having a couple of these and writing the current ratings on them so you can charge different cells and plug them on as desired. But once you've finished charging it, you can then get this stuff out the way. Use your little adapters to plug into this connector and have LED lights asunder. And the nice thing is that over time, when the battery finally goes down, then it will cut off when it reaches the lower voltage. It's worth mentioning I put 2 10 ohm resistors in series these lights just to control the current through them. But if you want, you can, if you're doing something like this, you can well, this is actually a little inline adapter. You wouldn't necessarily want to just plug it straight in because that would run the LEDs at far too much current, but you can choose the value of resistor you want if you're running LEDs or whatever you're running. Little standby work lights or anything you can run off little packs like this. They're extremely useful. Now, just before I finish this video, I shall bring in those pictures and show you specifically the resistor to change if you wish to actually adjust that to the sort of 500 milliamp level, not 500 amp. That'd be quite exciting. So let's focus down onto that. In the case of this type of circuit board, it's this resistor here. It's pin 2 of the TP4056. So it's this resistor here. You can either put in a new surface mount resistor or just tack on a standard 1/4 watt resistor. It might be easier. Just shape the leads so they both come in like that. And then fold it carefully over, making sure it doesn't short onto anything. With the case of this one, pin 2, it's this little 1.2k resistor that can get swapped out for a 2.2k resistor. And that is how you charge your cells properly without blowing up your house. So go out into the streets and harvest lithium cells from stuff, knowing that now you have the full protection to use them properly. Good result. Very handy little devices.